everyone, and welcome to today's meetup. Today, our session is being led by Ramsay and Nicola, and they are looking at the 3 layers of intelligence powering customer engagement. Nicola has written a blog on this recently, which I will drop the link for in the chat. And as always, the session is being recorded and it will be available on our YouTube. If you have any questions, we do save about 10 minutes at the end for questions, but if you'd like to drop them in the chat during the session or raise your hand, please feel free to. So with that said, I'm going to hand over to Nicola and Ramsay. Thank you.
Thanks, Madison.
So I'm going to start off with just a bit of background to ground our thinking in the topic. Excuse my analogies. I like making food analogies. It helps me make sense of things, and I hope it will for you too. So this topic actually emerged from a discussion that I was having with Jay a while ago about our algorithms and kind of what purposes they serve at different stages of customer engagement, or at least with dealing with the problem of knowing your customer and understanding and predicting what they're going to do next. What was revealed is that algorithms kind of sit in 3 different layers that perform very distinct functions. But we're going to get more to the technical details later, and Ramsay's going to speak to that more. I'm just going to start off with the basics. If we look at what companies are doing at the moment in terms of trying to understand their customers, there are a few common approaches that have been taken, one of them being demographics, which is basically the most basic descriptors of who a person is on paper, so their age, their gender, their income, location. And what's key here is that they're kind of static administrative facts about a person, and demographics rarely change. So once you know a person's demographics, there's certain things that you can infer about their behavior, but they're not really grounded in evidence. It's more just predictions you're making based on what people in that demographic have done before. Then there's generic segmentation, which is about grouping customers who look the same in terms of certain data points. It's usually kind of a combination of demographics plus some broad behavioral data like purchase frequency or product categories. What's important to note here is that segmentation is often applied from the top down. So a business will decide what segments are important here for a specific purpose or specific problem that they're trying to solve. So they might want to group people into high value buyers versus low value buyers because they want to reveal a certain piece of information, but it doesn't actually say much about the individual customers in those segments. And again, it's something that kind of freezes people in time, and it doesn't account for how their behavior changes. And then personas are a kind of hypothetical, fictional representative of who a customer could be. So the classic is like, meet Sarah, who's 34 years old, loves yoga, shops on weekends, values sustainability. It's not based on any real person. It's more a kind of aggregate of what a business thinks their customer looks like, and then they influence their product design or their campaigns based on that. And all these techniques are kind of geared towards solving one problem in a business, and that's reducing uncertainty about their customer. And they want to know something about their customer. They want to know that the messaging and the resources that they're putting into customer engagement are going to be successful. But unfortunately, these methods kind of focus on one aspect, which is looking backward and freezing people in a specific time, but also not looking at the right data, which is behavioral data. I was thinking about this morning. I made myself fried eggs, and the eggs were getting stuck in the pan. I kind of watched it from going from a raw egg to a fried egg to the egg on the toast. And as the process lengthened, how I had predicted my eggs would turn out versus how they actually turned out, the gap got wider and wider. So I was kind of thinking about how like a raw egg is much like trying to understand the past. So a raw egg is transparent, it's observable in its shape. It's likely not going to change because you're not really doing anything to it after cracking it. It's just sitting in a bowl. So it's very easy to identify patterns and understand what this thing is. And in the data science process, this would be the analytics side of things, where you're looking at past customer data and identifying patterns in it. And then moving on to the next way that people can reduce uncertainty is by forecasting the future. So you're taking past evidence and you're thinking about what could happen next. So like with poaching an egg, you're applying several different conditions to the egg. So you're applying heat, your technique, and you know from when you poached eggs before that when you boiled them for a certain amount of time, they're going to turn out a certain way. But every egg is unique and you never know how it's really going to turn out. So forecasting is all about extrapolating from like what you know and drawing a line, thinking about the trajectory, but then also admitting to the fact that things might not turn out the way that you thought, and then having the mechanisms in place to kind of learn from that. And then the third way to reduce uncertainty is about being able to learn from present actions. So like with making an omelette, it becomes far more complex because you're kind of handling the eggs as they're changing form, and you're also decisions in the moment, like reducing heat or changing the texture of the egg when you fold them, and you can't really undo it. So you have to take what you've done, you have to learn from it, and you also have to intervene while it's happening. So that's, in the kind of technical terms, the real-time dynamic layer, where you're dealing with behavior in real time and you're using your background of analytics and your predictions, but then also able to make decisions in the moment. So the important part about all of these is that they are inherently linked. So there's got to be a feedback loop while you're learning in the present. By the time you've applied your predictions to the present moment, your analytical layer is already out of date. So your understanding of the past has already changed, or should change to match the present moment. So everything that you've learned needs to feed right back through so that the gap can close between what you knew versus what you know now. And when you're dealing with humans, you have to combine all of these methods, and Ramsay's going to talk a little bit more about the technical details of each one. And yeah, I'm just going to put a visual aid here.
Yeah. So I think the first things to mention here, the egg analogy, I think is an interesting viewpoint. I think it works for a lot of points, maybe a few points it doesn't quite agree, but metaphors always don't fit 100%. But continuing on the analogy, I think what's important to note is all of these approaches have value. I think maybe the way you laid it out now, it seemed like you kind of did the first one that doesn't work that well, then did the second one that didn't work well, the third one is maybe the best. These are kind of all bricks or foundations that build upon each other. As you can kind of see in this graph here, it's kind of these steps that they build on each other. And each step you get useful information. To take the egg analogy, when you just have a raw egg, you can see that if it's rotten or not. You can see how big the egg is. Like, this is all information that is going to go into a decision about what you want to do with that egg. If you have an ostrich egg, you probably don't want to use that to make scrambled eggs because it's way too big. If it's a rotten egg, you probably don't want to eat it at all because it's going to give you salmonella or something. So there's a lot of information there. Granted, there's information that you're not getting, but you're still going to get information. Same with when you start cooking it. You kind of make these rules saying if you apply heat to it, something is going to happen. It's going to start cooking. If you apply too much heat to it, it's going to overcook. If you don't apply enough heat, it's going to curdle or whatever. So you're still kind of building this concept, this idea of how you can affect the egg. Even though this metaphor at this point, cooking it already seems that you're kind of influencing at the moment, but in this case, we're making it in such a way that you have to write down your whole plan beforehand and you can't adjust depending on what you see in the moment. You're just saying, I'm going to cook this egg. You're just writing down a recipe. I'm going to cook this egg for 10 minutes at 200 degrees, and then whatever comes out is what you get out. You only realize that after the fact. That essentially is your kind of forecasting. You have this idea, you've watched previous interactions, and it goes forward. This is all useful information. Once again, like knowing that these are these well-defined structures observed from the past, and seeing that there is value in building these forecasting, this kind of projections, and seeing that there is value to this, like that these people are behaving 90%, 70%, whatever, some kind of percent of the time within this bound of uncertainty. Gives you a lot of certainty around how customers behave, what are the bounds of their behavior. Obviously, there's always going to be outliers, and forecasting and predictive kind of analytics very rarely care about the outlier. But when you're the individual, you don't really care about the good enough answer. You care about something that is going to make you feel better or more likely to use the product or buy the product or whatever the particular customer is. That is where the kind of real-time intervention stuff is really important, because you want to go, how is this customer interacting with my system? As a starting off point, let's use the predictive analytics. Let's say we think that because a lot of people look like you, and because of your demographics and all of this previous knowledge that we've built up about you, that this is probably the best answer. Give it to them. And then they go, this answer was completely horrible. So you're trying to make an omelet and the omelet immediately explodes. Then you know, okay, well, clearly this particular egg that I was trying to cook doesn't like this recipe that I designed for it at all. So let's try something completely different. Let's, instead of putting it in there, let's put it in a cup and serve it raw. Maybe this is the recipe that this particular customer likes. They are confusing the egg and the customer here in this analogy, but I think it's clear what I was trying to get at. So yeah, definitely all these 3 layers are bring their own kind of part to it, and they are based upon each other. You can't do predictive analytics without having the historical data. You need historical data to be able to predict things in the future, and you need this kind of idea of a predictive environment to be able to do that in real time. So real time and predictive analysis is essentially the same thing. It's just at what point you are rerunning, retraining these models. So you're going to need this kind of continuous feedback loop that Nicola also touched on there on the second to final slide.
Like accurate to say that, you know, like, because if you say it had the top layer all by itself, you wouldn't really know. Like, you still want to set it on a trajectory. Like, you don't want to just send out a random message and then hope that people are going to engage so that you can then learn from it in real time. You kind of need the background of analytics and predictive analytics.
Well, definitely you do, because
what to send out in the first place. Yeah.
What is a random message? Are you going to set something that's going to create a random message of, I don't know, between 0 and 100 words where every word is random? That is a horrible thing to do. You're going to get 99.999% of the time, you're going to get absolutely garbage, nonsensical message. So already the act of deciding, here are 10 messages that I think will do well. I don't know which one as well. That is already understanding the past. You went into the data and said, like, this is a cell phone company. I want to sell some cell phone things. That is information about the customer and the company that you have now. You are looking at the past to try and influence the future. So that is just an approach. Without understanding what you're trying to do, it's complete nonsense. You can't do anything.
Yeah.
That's why the foundational steps are always important. You need the first step, then the second, then the...
Do you think also, because I mean, like I touched on earlier, demographic-based segmentation, stuff like that. Like, if you're starting with a foundation like that and working your way up versus starting from a foundation where you're using something like then personality to create behavioral features that you're then using in your analytical database, like what would the difference be then?
It's a difference in kind. I mean, it's like comparing apples to oranges. So the one is saying, I think that the world is shaped, you're making hypotheses. I think the world is shaped like X. So I'm only interested in using this set of data points, these demographic data points. There's a very good chance that you're going to get something useful, maybe not as useful as you want, but you're going to get something useful out of it. Then you go and you kind of, which might also be, you only have this continuous feedback loop at the top, but also like this analytics part of the forecasting part as well, this feature engineering, trying to figure out how to best describe your problem in the data. That's also a very iterative process. You kind of try new things, you make hypotheses about how you think customers, how their behavior can be viewed through data and how you can manipulate that in a sensible way to get information out that is useful. So like you now mentioned, getting behavioral data points about them, saying that this person is explorative spender or whatever, or enthusiastic spender. Like these are ways of viewing the data. That almost a bit jumps into that concept that you mentioned earlier about the personas. You're kind of creating these useful personas and saying that the idea of an idealistic spender or a whatever spender is this. We think they look like this, they behave like this, and we decided that to categorize them in this way because we think it's useful. We think they are distinctly different from other groups that do not behave like this. And for our particular use case in the business, we want to treat them differently because we know that they behave enough different from each other that it is useful to do so. So you can promote other products with them or promote other ways of interacting with the company with them because you know that they will like it differently. But this, once again, is a generalization or a segmentation. So it's all at the end is the ultimate segment or the ultimate persona is the individual. So it's about deciding at what point do you want to service these customers. Obviously, it's always the best to service them at an individual level, but it's going to be a function of computing power. Are you able, with the amount of data that you have about individual customers, to handle the complexity of the problem you want to solve? So it's a sliding scale. The more data and the more complex the problem is, the less granular you can get. You're going to find that point at where you get the best results for the least amount of resources. Some problems, even though you have a lot of data, they're very simple problems and you don't actually have to look at them at a granular level because you'll still get incredible results at the very high levels of granularity. So it's all about finding the sweet spot in your problem.
Yeah, but personas are also quite distinct from behavioral archetypes in that they're not actually based on.
Yeah, sorry, I use the personas now as a touch point, but the personas are more as a sales approach. In a way, it's a way of like explaining segmentation where the archetypes are.
It's meant to, I think it's more used in product design to kind of like evoke empathy, but in terms of like engagement, maybe not so much. But I wanted to talk a little bit about like zoom in a little bit more on spend personality, because I have observed before that spend personality can be kind of used throughout all three layers. So in the analytical section, you're running a database through, or an individual customer's data through the spend personality algorithm and getting a score, which is then kind of static and frozen in time. And then you're using predictive analytics to decide or predict what they're going to do next based on their personality score. And then it moves through into the real-time dynamic intervention where you can observe their behavior, see if it matches up with what you predicted their behavioral archetype was, and update your findings, and then rerun the data. So I mean, do other algorithms that we have function like that? Can you see algorithms functioning at several different levels?
I think the idea of the algorithms functioning at the different levels is not the right way of looking at it. It's like the algorithms do a thing. They generate data and you can use them at the different levels. So it's not so much that the algorithms function is like, is this particular algorithm you're using, is it useful at this level? Generally, the answer is going to be yes, in some way, shape, or form for most of them, but some of them might be more useful at certain levels than at others. Like just to use the spend personality now again as an example, you can just look at the past and say, let's look for all of the data I have for this individual. I have 2 years of behavioral data for them. I'm going to take that and run a spend personality on that. That's going to give you an answer that tells you something. But because you're looking at the 2 years set of data, it's probably going to give you some kind of average view of how they behave over those 2 years. It's not going to tell you how they change over that time. You can potentially take a snapshot and say, let's look at just these 3 months, these 3 months, these 3 months, and then get those individual snapshots and try and break it up over those times. That's one way of kind of doing this analytics and maybe see change over time. Probably not, because at the point where you're going to start using it, it's what you know about them now. Like you don't care if they were some way in the past, if they're not like that now. So you potentially just want to do this in the kind of top level, in the real-time dynamic intervention, and don't use their whole data, just use, depending on the kind of the speed of interaction, the rate of interaction. You may want to say, let's look at the last month of data that we have about this person. In the last months, this person has been incredibly experiential. So they are currently in their experiential phase. So let's treat them as an experiential spender. Even though they were, for the last 3 years, we've known about them, they were nervous spenders for all of the time. They're not behaving like that now, not in the data that we're seeing anytime now. So they change over time. So at that point, using our historical data that we have is almost a hindrance. Like, it's not useful for us to know what happened in the past that much.
There's also
But for something,
the flip side of that is also like when there is an abnormality in behavior like that, like it could also be the case that someone was just going through a very strange time in their lives and behaved very differently for a month and then just returned to who they were before, or even a shorter space of time, like something, a specific situation happened. So how do you make sure that your kind of like analytics don't put too much weight into abnormal behavior, but then also put the right amount of weight so that it's still accounted for?
yeah, that's the exercise in tuning. So it's basically trying to find that convergence rate that works for the particular use case that you're using. So in sales, we talk a lot about anomalous events. Like, let's say you are selling data for a phone company and there is a big football game on this Saturday. They'll find that there's a lot higher rate of airtime and data sales because people want to go and look at their sports betting apps so they can bet on the games. If there is then some week, let's say there's always a game on Saturday and all of a sudden I don't know, there's big weather happening, so no game this Saturday. That's an anomalous event. You could have pretty much said every Saturday there's going to be a spike of data sales, so promote the data sales as much as you can. Now the weather did something that's not true anymore. So do you want your systems to pick that up and go, this is a thing that we should take into account? Obviously, if you really want to be intent about it, you can go and add these all of these ideas you have of how stuff can be abnormal and kind of bake them in, like pull weather data for each area and try and bake that in. It's going to get completely complicated and spin out of control very quickly when you try to look at all the edge cases. So instead of trying to do that, it's better just to kind of have this idea of dynamic refactoring. You just go like, I think this is what we should do, but currently nobody is doing what I think we should do. So I need to adjust. That is that kind of real-time intervention feedback loop. So as soon as you see what you're doing currently, you don't do it anymore. It's not working. Adapt, adjust. So what time period do I need to do that for? That is the scaling exercise. If you say if after a day rates are very low, start changing it, that could work for certain use cases. You could say some use cases it could be after a week, some could be a month, some could be hours. It's going to depend very hard on the particular use case that you're working on and how sensitive to change you are. Like, how bad is bad recommendations for a few hours going to be for your company? Is it going to completely shatter the experience, and you're probably a bit more risk averse, so you don't want to have the changes happen quite so fast? Or if you're more open to risk, then you can make those convergent intervals a lot higher. So it's basically, how do you want to steer your ship? Do you want to be a jet ski that can turn very sharply, very quickly, or do you want to rather stay the course and only change when it's clear that change is the only option left at this point?
One of the use cases that kind of comes to mind that uses all three layers is churn prevention. You're observing a specific customer's behavior over time, and you see that there's an irregularity, and then you send a message or intervention to try and prevent it. Can you speak a little bit more about how that works?
Sorry, I missed that first part. Talking about customer retention.
So yeah, like churn prevention.
Yeah, churn. Yeah, cool. That's what I thought you said. I was just wanting to double check. Yeah, I think churn is actually a bit of a hard one because I think we've had this idea at the point where you realize the customer is churning, they've already churned. Like, it's actually very hard to retain a customer once they kind of made up their mind that they want to leave. I mean, unless you do something stupid like just giving them free service for a year. Obviously, there are ways around it, but not for a business sensible way. So I don't know if that's the best case, but I think, especially when you're looking at the historical data, you said we know that person X churned because in the week leading up to their churning, they did these things. And usually what you'll see is these things, if you're, let's say, in a banking environment, they transferred all their funds to another bank. And at the point where you say like, oh, they transfer all their funds, like that's not very useful at that point because they already left your bank. They just haven't closed the account or something, you know. So a lot of the big obvious things are not really indicators, but they are consequences of them having churn already. So it's not so much, I think, especially when you're looking at churn, you don't want to stop people when they have already churned. You want to make sure that they don't churn in the first place. So you can't really nudge a person after they've decided to churn into not churning, like giving them a slightly better special. I mean, they're already at that point fed up, and the mental entropy, it's going to be very hard to move them from that thing. So it's more around, you want to go give the customer kind of the base experience. So implement this whole kind of customer facing continuous feedback loop and try and give them the experience, the interactions that they like the best. Now, when you talked earlier about the kind of demographics, it's a good starting point for grouping people up, but you're always going to see outliers. Just because you live in a fancy part of town or a certain age and make a certain amount of money, that is not indicative of your behavior, not a causation. So you'll see that a lot of people who fall into certain categories behave a certain way, and that is useful in average, but it's not going to be useful on an individual level. I think it's important to mention that as well, as it does come up quite a bit. Yeah, sorry, like that's maybe not the most useful answer to the question about churn, but it's one of those cases where, yeah, it's preventative. It's not intervented. Yeah, you can't intervene into churn. You can try and restrict it.
Yeah, but it is also like what you said, like you can also look at what led up to the moment and kind of compare behaviors of other customers and see, like what are the typical patterns that people show just before they're about to churn.
Yeah, but like I said, that's the problem. It's very hard to see that, because the things that you see is 99% are going to be not indicators, but symptoms of churn. I
want to reach out to the audience to see if there's any thoughts, questions. Yeah, please feel free to ask.
There aren't any questions in the Q&A at the moment.
Well, Madison, do you have any questions?
No, none from my side. My question is, does anyone else have any questions?
My only question is, can you share this deck with us?
I'm certain that Nicola will be glad to share it with you.
Thanks.
You just have to see that she removes that spelling error there, continuous feedback loop, because it talks about the delta and not the delta.
No, Ramsay, I was just looking at that earlier as well.
This thing is generated. Yeah, Notebook LM does some strange things when you feed it text. You can also see it in that if you go into the blog link in the chat, the diagram is also in that blog. And if you just scroll.
Oh, cool. Thanks. I'll check it there. Thank you.
Yeah. I mean, I think we covered most things. I'm not sure if you had any other things you wanted to touch on.
Yeah, I think from my end, just to reiterate, is all 3 steps: your analytics, your kind of
understand,
predictive, but it's kind of very key kind of statistical function of like how you interact with customers. It's first step, kind of describe the problem, describe like the data, understand what it is, understand your relationship with the customer, what you want to do for them, understand, describe it. Once you've described it, you can then try and make forecasts, make predictions, make ideas about how the future is going to play out, make hypotheses. That is a lot of times going to be based on your understanding of the past. And then once you've made those predictions, you need to be able to kind of improve your predictions. And that can be done in batch format, where you just do it every now and then, you get new data. And that is also kind of influencing the presence. I feel there should also must be like a sub-step here between, there should be a sub-step between the top and the middle one, which is kind of like continuous or real-time dynamic intervention versus just like batch intervention stuff. But yeah, you can then use that information that you get from these stuff and retrain your models very slowly. And that's useful for a lot of cases. It's very useful, but it's once again, the next step up is then going to be the real-time dynamic intervention where you are taking what you've predicted and seeing what's happening in the real world, like looking at that egg in the pan and making sure it's not overcooking. You're adjusting, you're scooping it using the spatula, moving it around until you get the perfect omelet with all the little ingredients in there that you want. So yeah, so people walked up with that idea in their head, and I'm feel like it's still successful.
I feel like when I look at this diagram, it's kind of just what intelligence is in a way, like our intelligence as well. It's like we act from what we know about the past, but we're also continuously trying to predict what's going to happen next, and then interacting with the real world as it happens and adapting as we need to.
I think what's maybe also important, like you said, like, it's all intelligence. That's true. So why isn't it one block? I think what's important, why this is also separate blocks, is you'll find in most corporates, it's distinct skill sets that do these things. Your data analysts and your kind of data scientists and your ML ops, these are different people and they work on different parts of these processes. So it's, yeah, that's also why, like, it seems like maybe this could all just fall into one concept, but it's distinct skills and the kind of teams that will focus on the different blocks here, and they all feed into each other, but they take different skill sets to do them well.
Yeah, and I guess also doing it well requires you to be aware of what the other layers need to be useful, which I do wonder that's lacking sometimes. But yeah, I think we had a great discussion. Thank you, Ramsay, for giving the technical backbone to the session.
Thank you, Nicola, for creating some slides. So I didn't have to.
Egg analogy. Yeah.
Thank you both for the analogies. They were really helpful.
Yeah, at least it wasn't my pasta server analogy.
Thanks, everyone. Guys, thank you.
Thank you. Thanks, Nicola. I just want to say, yeah, making the perfect eggs is difficult in its own right. The data is a bit of a bigger challenge to nerds like but yeah, we'll get there. Thanks, guys. Thanks for the informative meeting. Have a good one.
Cheers, Barris. Cheers, everybody.
Cheers, guys.
Bye.